let's start with what's happening today. So this letter went out. Let's talk about the origin. Let's talk about how we got here.
There are lots of big changes happening at the federal level right now, and there are sweeping cuts proposed to lots of the agencies that are run by the federal government, and a number of the ones on the chopping block right now are the agencies that fund research, and lots of the types of research that matter to people in Montana. And so the letter was prompted by concerns over the drastic cuts that have been either started to be implemented with an executive order for the National Institutes of Health or proposed, like 2/3 budget cuts for the National Science Foundation. These types of cuts will cripple the research infrastructure in the state of Montana. And many of us are concerned about our ability to train students in science and to do the science that we do here, which we feel benefits Montanans. So the letter was motivated by the crisis, the fact that on March 14, the legislature is going to be deciding on the budget for the next year. And in that current draft are drastic cuts to science. So we wanted to try to get the word out to let Montanans, so that people would be aware of the consequences of these cuts if they go through. And it was amazing how quickly people rally behind that. There's over 100 scientists from the University of Montana that helped draft and sign that letter.
It's really, really important to understand it's not just the financial impact, but it's the impact on Montana students. And on a campus such as ours, where the processes of education and research are so intertwined and really can't be separated, that it's going to have a significant consequence on the way we train our students. I mean, if faculty can't do research here, researchers will leave. That means we won't have researchers that are involved in discovery teaching our classes. It means that when students really want to get hands-on internships, experiential training, things Montana understands. It's outside of the classroom, very important for their career goals, to make them more competitive, to open up opportunities for them. All of those opportunities are going to be gone. And that's a significant loss in the quality of the education that Montana students can get at institutions like here at MSU, at any research level institution. That's an important component of what they do, is involving students, and that will be lost.
Is there anything you'd like to add?
Yeah, I think I would underscore the impacts that it will have to our student body. Our students, rightfully so, are worried about those experiences that they're going to have in the summertime throughout their school year, to work with high-impact faculty, doing cutting-edge research. And we want to make sure that that University of Montana becomes and still is the place where students can come for the best education in the state of Montana.
Now, you'll have to excuse me, I just have my questions on here. So I always like to ask this question, but why should the average Montanan care about this?
The research we're doing on our campus is helping us understand our natural resources and how we can keep having those resources for our Montana public. We're doing research on wildfire, we're doing research on clean water and clean streams, we're doing research on our snowpack, we're doing research that impacts our outdoor recreation in the state and the economic impacts to small rural communities.
I think there's so many ways that people in Montana can look around them and think about the things that matter to them. It might be their favorite elk hunting spot, and whether the numbers are up or down, or whether the elk are moving across the landscape in the ways that they used to. Or it could be chronic wasting disease, which is something that scares all of us. I mean, what is a prion, and how does it work, and how long does it last in the soil? These are the kinds of questions that you can only answer with science. And Montana State University, the university system in the state of Montana is the place that trains people to do that science and to tackle those issues. So whether it's the newest cancer treatments when your mother goes into the hospital and gets diagnosed with cancer, or whether we're talking about new strains of crops that are more resilient to changes in soil or changes in drought, those kinds of advances, I think, matter to all Montanans. And the way that we make those advances is through science. And the university system in Montana is the place where that science is centered and done, and even more important than that, it's where we train the scientists that are going to do it tomorrow.
Okay. We're training, and I think, in my area, having worked in the School of Pharmacy for many years in the neuroscience department, focused more on biomedical and the health fields. But I think not only Montanans, but everyone in the country is worried about health issues. And if you look at the number of drugs, just impactful drugs, whether they be anti-cancer drugs, the new drugs like Ozempic that are treating diabetes and helping with weight loss, all came out of basic research. And that basic research is what sometimes takes place 20 years before that drug or that therapy will reach the market. But it's that basic research that sets the foundation, and that's the type of biomedical research that goes on campuses such as ours. The other thing in the health field is there are issues that need to be addressed in Montana because it's a rural state. For example, how do you treat stroke in a rural state? It's different than if you have a stroke and you're in New York City. And so what are the therapies? What are the strategies? And those can only be studied in those rural states. And if you take away the universities, you take away the connections between the universities and the hospitals, and all of a sudden you're at a loss of how to even address those problems or ask those questions. And so we play an important role in the biomedical field of training the physicians. I mean, the residency program is here on campus for one of Montana's residency programs. How we work with the hospitals, how our students that are pre-med students do their research before they go to medical school. All of those are going to impact the quality of healthcare in this state. And the really tragic issue is probably no one's going to notice for several years, but when that research history has been cut off and that research tract is no longer happening, then 10 years from now, the drugs that would be discovered now won't be available, or the therapies won't be available, or understanding diseases like Alzheimer's disease and what's causing the memory loss won't be understood.
So back to your issue of why should Montanans care? I mean, so many of the pressing issues of our day, and particularly the things that matter to Montanans, are things where you need a scientist to solve the problem. I mean, that is the only way we're going to make progress. And the scientists that are out there on the landscape right now in Montana, most of them got trained here at the University of Montana, Montana State. They got trained here learning how to do science that was directly relevant to people in Montana. And places like Montana are going to be especially hard hit by these cuts. But just to be clear, this is a national issue. I mean, this is really about whether the country wants to be a leader in science or a follower, because if they gut the infrastructure that funds research, there's no scenario where the United States maintains itself as a leader in that arena. New technologies, new batteries, new weapons, new everything that you can imagine that comes from science. I mean, the United States is either going to continue to invest in science and be a leader, or it's not. And other countries like China or India are going to step into that fold. They're doubling down and investing in science like crazy. So this is very much a national issue, a national security issue, a quality of life issue. But I think we feel it's a particularly acute one for Montana, because places like Montana can't do this kind of research without the university system. Other states maybe have, urban areas might be able to continue through other types of research centers to do research, but it means if Montanans want their kids to go learn how to do science, they're not going to be learning it in Montana. And when they go learn how to do science, they're probably not going to be doing the kind of science that is relevant to Montanans.
Well, and it's interesting, our researchers and scientists on our campus are very concerned about the state and doing work that's applicable to the state of Montana. You mentioned a lot of our scientists who are out there across the state doing the research. A lot of us here are really committed to working with the state on their most pressing and trying to apply our research so it impacts them directly on the ground. We can think about this across our other units like education. We have our leaders in the College of Ed. They're working with school systems to develop cutting-edge science and approaches to fit Montana rural communities the best. And so I think it's really important that our researchers here on our campus are caring about Montanans.
And you touched on this with that, but Parker thought of this question on the way over. But so, with that impact on funding, you're going to see students go to Oxford, and people tapping into that. So it's this would really hurt. It seems like universities in every state. Now, another thing is that I wanted to ask is how much money is at risk being lost from these cuts?
So if you look at the amount of funding and research that comes, say, from last year, from 2024, NSF provided about $15 million in funding for research here, and NIH about $20 million in funding, and portions of that, depending upon what new regulations are put in place, will be cut. In the instance of NIH, right now the big argument is over the cost of overhead that's included in the grant, and that's a very difficult thing to understand. It's hard enough for us to understand it, let alone the general population. But essentially, overhead represents money added to a grant that allows a university to actually support and provide the infrastructure for doing that research. So for example, when I write a grant, it doesn't include the cost of the equipment in my lab. It doesn't include repairing any of the equipment. It doesn't include the lights. It doesn't include, you know, all of the infrastructure we need to do the science, and NIH realizes that, and so that's included in those overhead costs. Overhead costs also include actually a lot of the funding for the compliance regulations to make sure the money is spent efficiently, that we're buying the things for the grant that only relate to the grant, that we are hazardous chemicals that we work with are properly disposed of, that if we use any animals in research, that it's being done very ethically. And probably most importantly, it controls all of the budgets. So the people in the staff in the research administration on campus make sure that the money is being spent the way it should, it's being spent efficiently. So it's really kind of ironic that the cuts being made to NIH in the, speaking of increasing efficiency, are actually the oversight, making sure the money is spent efficiently and on target and is used as proposed and not spent inappropriately.
You asked a little bit about like how much money are we talking about. I mean, quick estimates are a third of the revenue for the University of Montana comes from the indirect dollars on research grants from federal agencies. So you're talking out of the gates, a third of the revenue for the University of Montana. It's probably comparable for Montana State University. And so this is not a subtle effect here. This is crippling the infrastructure. Quick estimate that I got from the research vice president yesterday is over 100 faculty and almost 500 staff would lose their jobs because those salaries are paid for from the indirect money. That's the other thing Rich didn't mention. It's not just the keeping the lights on and maintaining the genomics core facilities or the microscopy facilities. It's the salaries for the people, the technically trained staff that help do that. And those people support students. So back to the why would it affect students? We wouldn't be able to do state-of-the-art research without that infrastructure, and we wouldn't be able to do that research without the staff and the trained people and the faculty that help students learn how to do that. So we're talking about dismantling the capacity of university systems to do science. It's that big a set of cuts that we're talking about. I mean, literally universities like the ones in states like Montana would probably have to abandon their research mission entirely and switch just to sort of small teaching college style teaching classes, which is not, we think, the best way to train tomorrow's leaders in science. You have to learn science by doing science, and the really motivated students want to go do science that matters. They want to do impactful science that's relevant, and you can't do that without having major research centers like we have here at UM and at Montana State. And those are literally on the chopping block.
For example, we are filming today in the genomics core. So a core is a collection of technical staff and equipment focused in a particular area of technology and science. And by having a core, it allows students and faculty from multiple departments to come and use that equipment. So it's a very efficient way to share that technology, to afford high-cost equipment. So that if I write a grant and I need a piece of equipment, I can say, oh, this core exists on our campus, and I can go do my genomics research and get my sequencing done in this lab. It doesn't have to be part of my research grant, but my grant is dependent upon having access to that technology and to that technical expertise. And that's what's going to be lost. So I wouldn't be able to do my research, even if my ideas are really good, because the equipment and the technical expertise won't be on campus any longer.
Is there anything you'd like to add on that subject? No.
There's really no subtle way to put this. On March 14, or by March 14, Congress will have to approve or not the proposed budget. And if the cuts that are being marked in there and put in there right now, if those things persist, I mean, unless our legislators are able to stand up for Montana by putting the funding back in place for science, all of this infrastructure is going to collapse. I mean, universities will not be able to train students to do science the way that we have in the past. We will not be able to figure out what's going on with chronic wasting disease, for example. Those kinds of problems are real, palpable issues that matter to Montanans. But the people who would solve that problem are the people that we're talking about, either losing their jobs or the students that we would be training that would solve those problems tomorrow who won't be trained anymore in those types of topics.
Is there any idea how immediate these impacts would be felt? I mean, would it be like next year?
Well,
Now?
the impact would be felt, it would be a chain reaction that would be started in the labs, and essentially people can't do their grants and they can't do the research they want because the infrastructure is not here. Those faculty leave. We can't train the students. Those students don't pursue or go somewhere else for their science. And then the research they would be doing and what they'd be discovering, then 4 or 5 years in the future, that would be felt. So it's something that is going to be long-term, and even a short interruption of disrupting that chain is going to have long-term consequences on just all of the good things that come out of doing research, whether it be in the ecological and environmental sciences or in the biomedical sciences.
To be clear, researchers have felt the impacts of these cuts already. There are scientists all over this campus who have had their funding pulled or who are not allowed to move forward with some of their research initiatives. And so, like Rich said, it is going to have a chain reaction, but we're starting to feel those impacts as recently as right now.
Okay.
I want to just touch on another thing too. I mean, I think there's a bigger philosophical issue here that is a national issue again, but it's one that's particularly relevant to Montanans, which is really who should be doing the research. Do we want universities to be the primary centers of innovative, cutting-edge, curiosity-driven research? That has been the model in America since at least the Second World War, and it's a partnership between the federal government and university systems where they negotiate these indirect rates that we've been talking about, but they basically negotiate with the universities what it costs to do research there, and then the universities are essentially given a green light to invest in the people and the projects, and then the government pays them back, reimburses them for those expenses. And what we're talking about here is the federal government failing on that promise and not reimbursing the universities for money that they've already laid out from this partnership. So it feels wrong on that level. It's reneging on a promise. But bigger than that is this sort of broader issue is, should the federal government be paying for science, and should that be done through the university system? Lots of people have argued that it would be done more efficiently if it was all done at corporations or through private foundations. And I think it's really important for people to think a bit about what that means. If it was done by a private corporation, then the science that's done, the discoveries, the patents are owned by that corporation. That's not going to benefit you or me necessarily. It's going to benefit that particular company. If taxpayer dollars, federal government money pays for science, then it's public. You guys, taxpayers, all of us paid for that science. It's our science. It means that the results that we come up with are public, it's transparent. Everybody benefits from that kind of science. So one reason to keep the federal agencies funding science and to keep it done through universities is that we all benefit from it. The other reason is, where do the scientists in all those companies come from? Who trains the scientists? We do. It's the faculty at the universities that teach people how to do science. So maybe in the short term you'd save a little bit if you didn't have to put that money into a university, but oh my God, where are the scientists going to come from in 10 years? Because as Rich said, it's a chain reaction. We train the scientists of tomorrow, whether they're going to work at a university or in a corporation. The companies aren't training the scientists. We do that. And we're talking about crippling, literally dismantling the capacity of the university systems across the country, and absolutely in Montana, to do that.
And that includes all the students here that are going into healthcare fields. They're all getting research experience, they're getting clinical experience based on the ability of us to have grants and to operate those facilities and those projects. And they're not going to get properly trained.
Right now, students can come to the University of Montana and they can work out of the classroom, in the lab, in the field, working, shadowing. Students here get incredible mentored research experiences from the faculty. They work closely with faculty in ways that you just can't do at the bigger universities, shoulder to shoulder with world leaders in many cases in these fields. Those kinds of opportunities are priceless. The value to Montana is almost indescribable of having people that good doing science that relevant here. And literally in 2 weeks, that might be over.
And that's a really good segue into my next question, just because I think this sort of contextualizes things for the average Montanan. What kind of research does go on here? Maybe something that they don't even realize goes on here. Is there anything that you'd like to clear up for people?
Yeah, I think one of the impacts I'm thinking about is our research on wildfire. The University of Montana leads the nation in wildfire research, and so a lot of our researchers right now are doing research on those mitigation strategies that help reduce wildfire impacts for rural Montana communities. And so we're looking at prescribed fire. We're trying to understand how prescribed fire decisions are made, how smoke from prescribed fires are impacting communities, and we won't be able to do that research moving forward. This is a big initiative in the state. All of our agencies who are working in Montana are thinking about how do we mitigate wildfire. And if we don't have that research funding, we won't be able to continue with that type of research.
You want to jump in?
Well, I think the biomedical research and the ability to come up with new therapies and drugs affects all Montanans, as well as across the nation. So it's in terms of, it's not as linked to problems like wildfire that are specific to Montana, with the exception of all of the different potential disease factors that come into being a rural community. And I think that's really important as to how to deal with different medical and disease issues in a rural state. You have to study it in a rural state. That's where the solutions are going to come from. And essentially we're going to be not on the playing field anymore. And it will be relegated to less important because we don't have as many people here. It's going to focus on areas of population centers. And by having research take place, I mean, that's one of the reasons that NIH and NSF feel it's very important to distribute that research across the entire nation and not just fund it in five of the biggest states, because they know there are issues here that need to be addressed that we can do the best job of addressing because we're familiar with the problems and we're very vested in their solutions.
And I want to jump in too. I mean, there's lots of sort of applied research that's incredibly relevant. So fire research and medically relevant research, but there's also a lot of research here that falls under the sort of basic science category, just really cool basic biology. How does life work the way it does? We've got people studying the physiological mechanisms that let mice and birds deal with extreme high elevation environments. Again, it's fundamental biology, interested in biology, but it's critically relevant to athletes and to physiology and dealing with low oxygen environments. We've got people studying how hantavirus spreads through small mammal populations, and whether if there's mice and voles or just mice in those environments, whether that influences the way that the mice behave in ways that would affect the transmission of the disease. There's people studying fish populations, there's people studying how plants adapt to crazy environments in the soils in Yellowstone where it's hot and salty, and there's all kinds of basic research going on. I have a graduate studying the architecture of antlers in elk and looking at biomechanical models to try to figure out when they break and why they break, and if some populations are more prone to failure in the antlers. So research goes on here in all kinds of topics, and that's part of the point. It's why this is an exciting place to have your kids come to college, because there's all kinds of really cool research going on.
But something I do want to touch on, just during my research, I saw that in 2022, the university was designated an R1 research institution. So we're not talking about, this isn't basic research. This is top tier in the nation. I assume that designation would just go away.
Well, absolutely. And I think for one thing, you have to be careful when you say basic research. What we mean by basic research is it means it's fundamental. It means it's not necessarily directed at solving a specific problem, but it's targeted toward gaining knowledge, and that knowledge base will then be used and can be applied to solve different problems. But both MSU and UM are designated R1 institutions. We are probably among the smallest R1 institutions in the country, and it's pretty outstanding the fact that we have faculty here that are that committed to doing research in a rural state. And so the impact will be felt and will be even greater to Montana if those two institutions essentially failed and are unable to do that research anymore, and they lose not only that ranking, but they just lose the capability to train students.
It goes into that ranking.
Right.
Yeah.
When you look at other states and larger states where they have, maybe 40 different universities or 20 different universities, here we have 2, and we're very reliant on those funding in order to stay as a research institution, which is a continual fight. Being a research institution in Montana is not as easy as being a research institution in Washington or California or New York. And so it's going to be even more impactful here because there are so few, and those are the only two opportunities available for our students.
Something I'm curious about, have students come up to you? Have they expressed concern about what's going on? And if so, can you share some of their concerns with us?
Yeah, we've been talking a lot with our students in the College of Forestry and Conservation. They're very concerned about future careers. They're concerned about their summer internships. They're concerned about what pathway do they have. A lot of our students were interested in working in federal jobs. They wanted to work for the U.S. Forest Service and National Park Service, and they're seeing those opportunities shrivel away. And so it's been really hard to work with our students on alternative plans. We have been partnering with our experiential learning and career services group here on campus to help them find other pathways for their dreams and their careers. But it is taking a really big toll on our student body right now.
I mean, a lot of our students are interested in pursuing graduate school and going on and being scientists with their own research labs down the road at other universities or back here in Montana. And nobody knows what that landscape looks like. Because not only will Montana be crippled, but many of the state institutions and lots of the university infrastructure across the country will be dismantled. So where do our PhD students go? I mean, if there aren't academic jobs on the other end and there aren't institutions training scientists for tomorrow. So I think the job market is scary and uncertain for students in lots of different areas, but particularly in the STEM, sort of science, technology.
Yeah, I also think it's really important to realize that not all of the students that work in our labs are going to necessarily go on to careers in science, but the hands-on experiential training they get in a laboratory is just phenomenal. It teaches teamwork, it teaches critical thinking, problem solving, using technology, learning what the newest approaches are and adapting them. So the skills that you learn that a student learns in a lab can be applied toward any career. And essentially it's taking away that component of the training that they could get here.
One of the reasons UM students do so well at getting into medical schools is because of the sort of out-of-classroom mentored research that's not simply shadowing a doctor in the hospital. It could be working on a rhinoceros beetle population in Japan, but it still helps you get into med school because it comes with all the things Rich just mentioned: teamwork, learning how to think critically about problems, learning how to ask and answer those types of questions using the scientific process. And you know, medicine is one of these fields that's changing, at least it used to be, changing lightning fast because of advances in science and technology. We need our doctors of tomorrow to be aware of that process and able to interpret the new results that are happening, because the treatments and the drugs and the things that are available for people to treat patients are changing almost week by week. And so if we're really going to train the doctors of tomorrow, they need to think like a scientist. They need to understand the science, and they need to be able to stay abreast of all of the changes that are happening out there. So again, I mean, that extra, not just memorizing stuff out of a textbook and taking tests, but actually doing science is what makes this place special. And we're very worried about what tomorrow is going to look like because of the proposed funding cuts.
You know, I think we touched on everything that I wanted to. Is there any subject that you all felt I didn't touch on? Anything you'd like to add?
Just the last thing, I guess, would be in terms of impact and efficiency. So year and year after year, in looking at different parts of the government and the agencies and their efficiency and how well they use their funding, the scientific agencies like NSF, like NASA, like NIH are probably the most efficient and generate the greatest return. The numbers I have at from NIH is about every dollar that's invested in biomedical research yields about $8 in economic impact. The other thing about science and in the investment of science that is a bit different from other government agencies is because the return on investment is permanent. If I or someone in a research lab discovers a new therapy or a drug, that drug is permanent. That continues to treat people, that continues to save money into the future. Whereas other agencies, it might subsidize something for a year, and then that project's over. The investment in science is investments in dollars that are going to continue to pay off forever, because they're going to continue to impact patients. They're going to continue to improve the quality of healthcare that patients can get. So it's a long-term investment, it's a long-term payoff.
The analogy, I'm trying to think who told me this, but it's a very apt Montana analogy, is cutting the sudden abrupt cuts to funding that we're talking about here. It's like eating your seed corn. It's like, it might save you a little bit in the short term, but it's not a good long-term strategy because you've got nothing for the next generation or for the next year, if you're thinking about that analogy. And one of the things that you mentioned that we didn't come back to, but I mean, have we ever seen anything like this before? I mean, I've been at this 30-ish years. My father was a research scientist. My grandfather was actually a research scientist. I don't think that this country has seen anything this drastic or a threat to the infrastructure of science anywhere like this, at least since the Second World War. We are talking about massive cuts. This is not a 5% reduction. This is a 2/3 reduction to the National Science Foundation operating budget. It's like, you can't do science like that, and universities won't be able to continue to do science like that. So I think for Montana, this is really a, do you want the United States to continue to do science, or do you want to be getting your new technologies from China? I mean, that's really what's on the table here. And then there's the Montana specific one. Do you want your kids to be able to go to school in Montana to learn how to do science? Because that is absolutely at stake right now.
And to have part of that payoff from the science, whether it be the results or the economic impact, occur in our state. Because it's the universities and that research that drives that development.